Hi, I'm Raghu and welcome back to another session in the series of programming a Raspberry Pi Pico using Python. When a Python program has no syntax error, it executes from the first line to the last line. However, in case the program encounters an error in between, Python stops there with an exception. For example, type the following in Thorny's shell window: print bracket D. When you try to run it, Python interpreter shows an error that name D is not defined. Just before the message, there's another word, name error. This exception happened because of the fact that we have not declared a variable called D, but we are trying to use it. Basically, what the interpreter is trying to tell us in this exception is that when I run the script, I found an error. The type of error is name error, and the error message is that name D is not defined. The normal behavior of Python is to stop executing the program when it encounters an error, also known as exception. What if we don't want to stop the execution but want to do something else? That's when we use the TryExcept block. The Python interpreter tries to execute the block under the try keyword normally. But if there is an exception in that block, the Python program doesn't stop there. Instead, it jumps to the code under the except block and executes this block, which means that the program doesn't stop when there is an error. Instead, it takes an alternate path. In our program for the touchless entryway, when we had to write values to the DB or read values from the DB, we used the TryExcept block. When we communicate over the network, there are several things that could go wrong. For example, there could be a momentary network glitch, due to which the program may not be able to communicate with the real-time cloud DB. If this happens, we don't want our entire system to collapse. Instead, we use a TryExcept block. If there is an exception, we simply print out an error message and continue with the loop. No big deal if we are not able to read the mode for one iteration or write the state for one iteration. We can try again. Did you observe that the except keyword in this code has some additional attributes? Here I've used except exception as E. You would use this when you want to use more details from the exception that you caught. In this case, I'm just using the exception message that the call function raised and I'm printing it out. In our example, we used a blanket except statement, which means that the program could have gone to the except block irrespective of the type of exception. What if we want to take different actions based on the type of exception? We do that by specifying the type of exception in the except block. In Python, just like an if statement, try statements can also have else clause. In this case, if the exception occurs, then the code under the except block is executed. If the exception doesn't occur, then the code under the else block is executed. Python also supports the finally keyword for exceptions. The block under the finally keyword is executed in both cases, when an exception occurs and when an exception does not occur. All along when I was talking about exceptions, did this question cross your mind? If we are trying to catch exceptions in our programs, how did these exceptions occur? Who threw these exceptions? Well, you cause these exceptions by raising them in your modules or programs. You can raise an exception using any class that derives from the base class called exception. In this tutorial, we've seen all the important concepts about exceptions in Python. We can now move on to the next topic. Hope you enjoyed this session and have got a good understanding of the concepts that we learned here. So let's move on to the next session in this series of programming a Raspberry Pi Pico using Python. So see you soon.